Okay, we're going to get going on our data log. Okay, why is nothing open? All right, so previously, last time, we implemented display for all of our stuff so that when we ran the tests, and we did this thing. We like constructed a program in a string, and then we constructed it in data structures, um, and and then we got it pretty printed out to something similar to what the original syntax would be, um, which was fun, and I think made it a lot easier to potentially debug some of these other tests if we wanted to take advantage of that. So we were talking about earlier. Let me check this off real quick. We did the release actions, and I'll move some of those things to the next session. Okay, so we need to verify range restrictions on rules, and I think the way I want to do this is there are multiple places we could check it, and I believe if we look at the version that we did in, or that I did solo in Elixir, we checked the range restriction right. So when we in the solve function, we checked is it range restricted to make sure that we could actually find a solution. Um, and then it called into the other functions that do the evaluation. So we could do something similar to that. Um, and probably, let's jump to what is, it's the solve function. Right, so I put a note here. We need to check range restriction. So let's do something similar. And what we'll do is we'll add a method on rule that checks for the range restriction. Um, and so let's do an assert here. So program dot zero. So this is a vec of rules. Iter all. Um, and then this is a rule. Rule dot is range restricted. Um, and that's probably good enough. So now it's going to complain that that doesn't is not implemented. So let's go up here on rule. Okay, we don't have an impl block for rule, so let's add that. Okay, so is range restricted. Self. And this returns a bool. Okay. So you can have free variables in the body. Um, if I recall this correctly. So let's go back here and see what we did in Elixir. Right. So okay. So we find the variables in the body, and we ensure that the variables in the head are a subset of the ones in the body. That makes sense. So basically, that's saying every variable, every free variable in the head of the rule is referenced in the body of the rule. Otherwise, you get divergence. Now, it is still possible to have divergence you have when you have a variable that appears only once in the body of the rule, but that's a different problem. Okay, so I think we can implement this fairly straightforwardly. Let's look at this. So we have terms implement EQ and partial EQ. Okay. And then atoms have vecs of terms. So probably what we can do is say something like, let's get the body variables just like we did before. So we're going to do self.body. It gives us a vec of atoms. So we're going to yeah, let's do so that's going to give us atoms. Flat map. Yeah, let's flat map. So this is an atom. Atom dot terms. We might need a clone in here somewhere, because this is going to be like yeah, let's just clone it. Because we're going to have to return something concrete here. I had a discussion about this with a coworker this past week, and he was like, why can't you return an iterator from flat map? I'm like, well, because so often you're it's an issue with lifetimes. So we're going to have to, yeah, let's just clone there. And then we're going to, so that gives us how do we turn on inline hits? Type. Nope. Okay. I don't know how to do that in Z. Okay, so now we have let's collect, and let's just for argument's sake, this is not body vars. We're gonna have to filter it again. Let's say this is a vec of whatever. Oops. Let's see what the type it says it is. Yes, this is a vec of terms. So let's filter that. And this is a term, and we'll say matches. I never remember which order this comes in. Okay, you always put the match pattern on the right. Okay, so matches term with term var. And the other possibility is that we should collect this into a set. Let's go ahead and do that. There's not really too much harm with it. Standard collections, hash set. And if we collect it into a hash set, then we will be getting a unique one. So does this, oh, it doesn't implement from iterator. Oh, no, the issue is term is not hash. Okay, so we should derive hash here. That's not a big deal. I was like, why wouldn't it collect into that? Okay, so now we have the set of body vars, and then we'll do something similar for the head, right? So we'll say let head vars, we'll say hash set term self dot head dot terms iter filter and we'll match on that again. And I think we want cloned. Well, let's see collect and see if it'll complain about that. Yeah. So this yields iter yields references, and we're trying to collect. Yeah. So we need to add the dot cloned here. But the nice thing here is if we put the cloned at the end, right before we collect, we're not cloning before we need to. So we're only cloning the vars. Okay, so now we just need to say, so similar to what we had in the elixir, we need to see, is it a subset? So let's look at what hash set provides. Hash set. Is subset. Okay. Is subset of body vars. And we need to borrow that. Okay, that was easy enough. So I think the test that we want to write here is, let's write a program where the this range restriction fails. So where it's not true. So that should be fairly straightforward. So let's go down here, and we will make a new test. Annotate this with test. Let's just test rules are range restricted. Okay. And so this is actually pretty easy to test. And then actually I think what we want on here is should panic, right? And how is that? Let's see. Should panic. Let's search for that. Should panic. That is not what I wanted. Test. The test macro. Let's just look at the testing chapter. Yada yada. Test. There is a should panic. Here we go. Okay, so it's a separate attribute macro. I forgot that. Okay, so should panic. And then we say what we want to do is construct a program where you have a rule which has at least one variable in the head that does not exist in the body. This is actually really easy to do. So I'm going to copy this and say let program it's going to be program vec. And let's make a rule, and it's going to have a head, and we'll say body have no body, and the head has variables in it. I think this is the easiest way to test this. Okay. Yep. Let's call it range unrestricted. And then we'll just have one variable in there. Right? Okay, and then we'll call let result solve program. And that should panic. And if we are not mix cargo, let's see what happens. Okay, So our example failed by default, but rules are range restricted, should panic. Okay, so that's good. I think that covers that functionality. Um, the other possibility is that we do something like we put another atom in the. Yeah, let's just copy this. Um, range unrestricted y. So here we have a case where it's a different variable than the one in the head, and this is still not a subset of what's in the body. That should still panic. Okay, so should panic. Yep. Now the other thing that I would like to do, I think, is just this is a toy. We're not trying to make this production ready by any means, um, but it might be nice to say why it failed in the assert here. All rules must be range restricted. Um, and then what we should get is this will be the message that happens in the panic. And we can say down here in our should panic, like what the message should be. Is it message? Oh, poo. What is it? Expected. Okay. Or should panic equals reason. Yeah, let's do that. Like so. And let's see if that works. I have done that in the past. I just don't recall. Yep. Okay, so that still passes. It shows that our message comes through when it panics. So that's good. Cool. We can check that off. So we have about 15 more minutes. Let's maybe make some macros. We do macros in Elixir. Let's do macros in Rust. It'll be fun. Um, so you can see like this stuff is really tedious, right? Filling out the data structures. Um, what I would love to do is something more like, so we can build this up from the bottom. Um, and I think Rust macros are pretty fun. They're not declarative macros, at least, are not as powerful strictly as Elixir macros, but they're very close. So let's look at macro rules, and we can look at macros by example. This is useful. So there are various types here, um, and we probably want to do stuff like yep. So let's start small, um, and let's jump back up here, kind of toward the top. At some point, we're gonna have to like organize this into some files that make sense. Um, yeah, so let's jump up here to term, and let's just make some rules here for constructing these that makes them a little bit easier. So we'll do macro rules, and let's name this term. Or no, let's name this var. And we only care about one, which is we're going to have, was it name? I have to remind myself. Dash. Okay, so example. So we have a dollar and then the the thing. And so this is going to be a literal, right? Literal. Okay, easy enough. So then we'll go term var name toString. So this will take, let's split right so we can see some of the tests. So like where we have term var x toString, we can just go var bang x, var bang y. That'll be nice. And then let's do a similar one for sim. Now let's call it symbol. Be nice. Name is literal. And then we'll just do term var name to string. So now it's complaining it's not used. That's to be expected. So let's go in here and maybe let's start here because we have our example, which we we were just using the example from the blog post that this originally came from. And then we can let's start with that. So now this is interesting because maybe we don't want literal here. Maybe we want the other option is we could say ident, which is like a variable potentially, like an identifier. TT is kind of the throw your hands up, whatever, any set of tokens. It could be expression. Expression might be okay. Yeah, let's loosen this to expression. And then it's possible for it to be an identifier or a literal or whatever you pass to that. And that'll be that'll make this possible, because what I was looking at this was if the restriction on this token is it has to be a literal, then we can't do it right here because advisor is a variable name. It's an identifier. So let's see if this works, and we'll start with vec, and we'll say symbol advisor symbol student, and then let's remove that. And the compiler doesn't complain. So let's say pub. Where's that? Can you do pub? I forget. Okay. So now we have something that will shorten this up a little bit. So our symbol works. And now we could do like, let's look at the warnings are just about that. Okay. We could do something like, let's just run the tests and see what happens. So it's just complaining about those not being used. Our example still failed. Interesting. It says all rules must be range restricted. So let's back this out. It panicked on something different. Did I modify it? We might have an actual problem in our program here. No, so these are supposed to be symbols, not symbols are like literal values. So that's not the source of the problem. Okay, so here this rule should not be range restricted. Now what might be interesting is in that assert that we made earlier about range restriction, if we identify which rule wasn't range restricted. So we could do something like, where did that go? It was in solve. So we could do assert EQ rather than all. We could say vec, an empty vec. We could say filter filter the ones that are not range restricted, cloned, collect. What's wrong there? I think we just need to annotate it with vec here. Yeah. Type annotations new. Okay. Let's just say vec. Rule. That's really ugly, but do we not implement partial EQ for rule? Thought we did. We do not. Okay. So we need to do partial EQ, EQ. And now it's just complaining about the macros. So that was interesting. What I'm looking for there is, and this will probably make our other test fail because the should panic changed. But we're doing an assert EQ. Let's see what happens. Okay, so oh, do you see what the problem is? I just found out. We messed up the macro. So I did var here. It should have been sim. Now that should not fail. But that's a useful change to our assertion, because now it'll print out the rules that are not range restricted, right? Okay, well, our panic still works. So this test did panic as we expected. Okay. And we print out things correctly. Okay, so our refactoring there is good. Going up here. Z does not have find and replace, so we're not going to be able to do that. But I want to show in this example how we can make use of that. So we have symbol. Now down here, we can replace these with var bang, var x. You know, we're starting to approach DSL with this. It could be easier to write these things. And this one's also var x and y, right? And this one is x and z as variables. And this one is x and y. And this one is y and z. Y and z. Okay, so now we've all of the terms have a macro for constructing them, which is shorter. And the main thing there is just that, like, it was a lot of visual noise to write term var whatever to string, term sim whatever to string at all points. Okay, quick sanity check. Okay, we're good on that. Let's move up a level. Let's go to atoms. So an atom has a predicate symbol and a list of terms. So let's write a macro rule for that. Atom. Okay, so this is where we're going to have to use repeat. And we're going to say, we'll say predsim is, and we need $sign on that, is an expression. And then we'll have a comma. And then we'll have any number of term, which is an expression. And right, and that's star. So we should be able to define atoms that have no terms in them. This is not especially useful. They're sort of like unit structs in Rust. Their existence is important, but not necessarily their. They don't have any values. Okay, so what we'll do here is we'll construct an atom. We'll say predsim is predsim toString, because that has to be a string. And terms is going to be vec. And here we'll do term. We need dot term dot toString. There we go. Comma star. Okay. So let's try to replace this with our macro. So previously we did, we replaced this with symbol, right? Let's just push that out of the way and we'll redo it. So atom, and it takes advisor, symbol, advisor, symbol, student. That's pretty cool. Okay, so now we have a problem here. These need to be comma separated in the head, and missing tokens in macro argument. Okay, so I need to look at the documentation for this. I think there's a for repeats. I think I need the comma on the outside is what it comes down to. Okay, so the comma comes on the outside. So I need to do this and this. Oh, but we don't need to do term toString here because it's already a term. It has to be a term. Okay, that's pretty cool. So atom, that's shorter. So we have an atom advisor, which has two arguments to that atom, advisor and student. And we can go down here and we can do the same in these other places. So we can say atom, academic, ancestor. And it takes var x and var y. Okay, that's pretty cool. And we can do the same in here. Atom advisor var x var y. And we can delete that. Okay, quite a bit tighter. And we can do some funky stuff with rule that'll be fun. But let's get the basics down here in these other places. So this is similar, and let's just copy these out. So there's our atom. That was the head of that rule. And now the body of that rule is atom advisor var x var y. And then there's another atom in this rule, which is academic, which is the recursion. Academic ancestor var y var c. And we can delete these manual constructions. And that's quite a bit tighter. You notice we're getting a lot closer to the original Datalog syntax here, with just some extra noise. Okay, so we have a macro that defines atom. Now let's step it up one more layer and define one for rule. And this, I mentioned before, this is where we can get we can get really funky. Yeah, let's put it here. So for a rule, we need something which is the head of the atom, and then we need some things which are the body of the atom, right? Or the body of the rule, rather, which are a list of atoms. So what I want to do here, I don't know if it's possible, but we're going to try it. Because you can put punctuation in a macro rules. So what I'd love to do is go, so we'll say head, and for now we'll say it's an expression. I don't know that it's going to be. We might do something even funkier with atom, so that we can kind of lift things into atom. But what we want to do is put the Datalog separator. And we'll make two clauses of this, one which has the separator and one which doesn't. And we'll say, so this is body expression, and that's comma plus, right? Okay, so we have a head, and then we have a colon dash, which is the separator there. And so what we'll do here is, what we eventually want to get is, we want to get a rule, and we're just, for now, we're going to assume that head is the head, and the body is going to be a vec of body comma plus, like that. So similar to what we did in the other macro rule for atom, where we took the terms and we notice that the terms are optional, right? Here we have this extra syntax that's not Rust syntax. And then let's make, and this actually needs to be a separate clause. So these are sort of like pattern matches in our in Elixir, but not exactly. So let's copy this and just do an empty vec. So you could define it, yeah, and it's going to complain about that. Now we could just use fat arrow. Fat arrow is kind of cool. It can mess up formatting though if it's not a match, like a match arm. But let's look back at this. There's a limited number of punctuation that you can use. Right. Uh, yeah, I'm not sure what they're talking about there. I'm just mostly looking for what types, and maybe it's up in here. Token, okay, repeat separator, token accept delimiters. Um, so macro match is token accept dollar and delimiters. Okay, so you can't use so it's okay, so brackets create a token tree. So you can't use brackets. You can't use dollar. And what is token? So punctuation. Okay, so these are the valid punctuations we could use. And colon dash is not one of them. um, now we could use colon colon. That's not so bad. We can use a thin arrow or a fat arrow. Um, let's use a thin arrow. I know that's not exactly what. Okay, so it's not allowing that for whatever reason. Okay, so we have to use fat arrow. That's fine. Um, so we are here. Let's replace this one first. Okay, so we can do rule bang. And this is Adam advisor symbol. And let's just copy this. Actually, there's no need to. So this would be this would be the one without the fat arrow in it, right? I kind of wish you would put this on multiple lines, but so we're saying there's an Atom with advisor, and it has two arguments: symbol advisor, symbol student, and there's no body to it, right? So this is setting up our facts, so to speak. Um, and now we're going to have some recursive rules. So let's see if we can replace these. And I think there are other ways we can make this a little bit more terse, but are a bit more complicated. Um, and yeah. So there we have. Okay, so we have a rule that has academic ancestor X and Y, and it implies that, and I kind of want to put return there. There's an Atom advisor X and Y. Is it going to put that on the same line? No. Okay. So there's a little bit of noise being introduced here, where this, at least the original way, gave us a bit more variety um, in the syntax, but so we want this, and then we want these. And we can remove that. All right, let's see if it runs. Okay, and we're still constructing the rules correctly, because you can see them print out here. Um, and that's pretty cool. Now I'm not going to go and update all the tests today. I think this is a good place to stop. And so we accomplished our goal of getting some simple declarative macros for expressing these directly in your code. so that we can have a little bit less noise in all this data structure stuff. So let's make a commit. And what we did was, yeah, verify range restriction on rules and add decl macros for constructing programs. Now I could have made a program one and like has rules in it and so forth, but I don't think that we're it's I don't think it's worth doing that today. So let's push that to main, and I think that's a good place to stop the stream. I do want to take, if you all are still here, still plenty of people, good. I want to take a moment and talk about what should we do next. Because obviously the last two streams we spent on documentation for Hard Hat. We're going to do at least one more, maybe address those things that Eduardo brought up earlier in the chat, on the code side. And then there's well, we don't have a project. So I did put a call out on Mastodon. I'm on Mastodon. I'm on Hachyderm, by the way. If you aren't following me there, you can catch notifications about this, as well as I posted a poll. So the poll was about what should we do next, and there are three things that I called out, but I'm happy to hear suggestions. So first one is, a number of years ago I tried a project of in Elixir, created a compiler for a very simple language that wrote Beam assembly, and it was really fun. But there were some things I ran into that made it a little bit hard, and they were mostly about the source material that I was going from was based on OCaml, and OCaml has types, and you could check those types, and it made writing certain things a little bit easier. So my idea here would be, let's do this, but let's do it in Rust or in Gleam or something that has a richer type system than Elixir. But the goal there would be, so the material that this came from was our university course, and it was writing x86 assembly as the output of your compiler. It's like, okay, well let's try this. Let's do it on Beam assembly. So no Elixir compiler, no Erlang compiler. Even the Erlang compiler has some sophisticated optimizations, but I think it would just be fun to reveal what it takes to write a compiler, do a bit of learning myself, but also, well, what the heck is the virtual machine actually executing? What is it interpreting and stuff? So that's what does that look like? It's good to know. So that's one project. The other project, or the second project, is I have this what we call game night, a number of years ago at the Kansas City Elixir meetup. We have this thing where you write the mechanics of a game, and then the goal of the meetup is that attendees write a bot to play your game. And we did this to great success with a number of things. So easy games like card games. There was Connect 4 was the very first one that was run. We had Blackjack, we had Battleship, we had Stratego, we had Guess Who. So the idea is we'd do that. Well, a friend and I wrote a capture the flag game, which is basically you have a little tank, and the goal is to either destroy your opponent or get to their flag without dying. And it's just like a 20 by 20 grid or something, and so you have to give your tank commands to execute. Well, the visualization on this kind of sucked. I was trying to do, use Boyd Moulter's scenic framework to draw things, and didn't get very far. Well, Rust has a lot of burgeoning tools for writing games. So the second idea comes down to, let's take that meetup thing that we wrote in Elixir for tanks that try to get to capture the flag, and port that to the Bevy engine and let people script it with something. So Bevy is a really popular engine on Rust. This thing has the most votes right now on Mastodon. Um, it's also going to be the hardest, just fair warning, but it might be really interesting. Okay. The third idea is there was a tool when I worked at Postmates that we used to make preparations for the busiest days of our year, and that was usually the Oscars and the Super Bowl. So what do we do? Well, we were capturing metrics with Prometheus, and one of the most important metrics we had was, what is the number of ongoing jobs? So the number of deliveries that are outstanding. And that was a pretty good like business level metric for uh, like activity in all of our systems. So the idea of the capacity planner, is what it was called, um, is that you could take important business metrics like jobs, um, current ongoing jobs, or something else, and correlate them with other metrics, system metrics like what is my database latency, or what is my CPU utilization. So something that like would reflect the health of your systems, or what is my rate of processing some operation, and then so you could correlate those metrics. It would do the linear regression on them and push them into Prometheus push gateway. So not only could you do a one-time like offline type of correlation, but you could also track it over time. So if you like made some performance improvement, you could see, oh, hey, I have more capacity, or I'm requiring less now, or the relationship between these things has decreased, so I'm better off. That was really good for kind of like ongoing long-term understanding of how good our systems were operating. But it also meant that we could go and say, hey, we're preparing for this big day. We know it's going to happen. Uh, and somebody would say, hey, we expect X percent more than our average day. So you could say, let's look at this metric. Do what are we going to need to adjust on our scale factors to determine, say, how many EC2 instances we're going to need for this service, just as an example, or what is the database utilization on our production database going to be? What is the CPU utilization? What is the the latency going to look like at a particular scale? Now it's rough. It was always an estimate, but like it let us prepare for those big things. So this is a thing that I think like should have become public, but didn't. And I want to recreate it. So this will be a combination of, and I probably want to do it in Rust. I think that would be a really good fit. It'd probably be a combination of, uh, interacting with the Prometheus API, so getting the metrics out. Um, and then there will be some math. There'll be some linear regression. Um, there will be some pushing that on a regular basis up to the metrics server so that you can track it over time. Um, and then there will also be potentially, plotting that regression. So plotting the data points plus the fit line, and producing graphs. I don't know, with GNU plot or who knows what. Maybe we'll do an R script or something. I don't know what the latest hotness is. or we could hook it up to Livebook or something with Elixir. So there's a lot of possibilities on that. It's probably less of a fun thing than the CTF or even the compiling, but it'll be super useful. So, uh, if you have any thoughts, you can drop them in the stream chat about any other things you would like to see me work on. Or you can drop them as a comment on my Mastodon post, which I will share a link to real briefly, and then if you're watching this later on YouTube, leave a comment on YouTube. I do try to read all the comments. I haven't gotten many yet, but if you are watching this, please drop a comment there on YouTube. And then otherwise, we will see you next time. We'll see you on Sunday at the normal time, and have a great week. Thanks so much.